So, looking at your answers to the required prior knowledge, the expansions we just did above, hopefully you've managed to spot some patterns or wondered some things. Let's have a look at trying to make some predictions based off of them. So hopefully the first thing you will have noticed that when we do this, we start with an a to the power of 7 and we end with a b to the power of 7. Now you may have noticed some other things. The next term is a to the power of 6b, and sort of symmetrical, this one is a b to the power of 6. Now there is a number multiplying in front of these two. There is a coefficient for both of these, and you may also have spotted that in this particular case that's going to be 7. It always seems to be whatever the power was to start with. And you probably or hopefully realize that the next one is going to be a to the 5b squared. And down here we end up with something that is the other way around, so a squared b to the 5. And there is some number here, but it might not be particularly clear what that number is just yet. And then a to the 4b cubed. And indeed here the other way around, a to the 3 b to the 4. And again there is a coefficient in front of each of those, but it's not immediately clear what they're going to be. But you might have noticed some patterns here in coming up with this prediction. So for example, it always starts with a to the 7, ends with b to the 7. Might have noticed the powers of a are decreasing as we go along each term. The powers of b are increasing as we go along each term. You might also have noticed that those powers, particularly if we write in those invisible powers here, makes it a bit clearer what's going on. Those powers in each term always add up to 7. 6 plus 1, 5 plus 2, 4 plus 3 always add up to 7, which was our power here. That's also something you might have noticed. And we talked about the coefficients 7 and 7 here. And these other coefficients, it's not immediately clear, as we said, what they're going to be, but we will get there. So let's have a think about what a plus b to the power of 10 might be. Well, we're pretty confident it's going to start with an a to the power of 10. And we're pretty confident it's going to finish, I'm going to write it on the next line because there's no way it's going to fit on one line, as b to the power of 10. We're pretty sure it's going to be 10 a to the power of 9b. And then something times a to the power of 8b squared, and then something a to the power of 7b cubed, some coefficient a to the power of 6b to the power of 4, some coefficient a to the power of 5b to the power of 5, some coefficient a to the power of 4b to the power of 6, a to the power of 3b to the power of 7, a squared b to the power of 8, and then the last one we're pretty sure is going to be a coefficient of 10, and we get that. And that would be a pretty good prediction for what's going on here. And what we'll look at in a minute is how we can find these missing coefficients. But hopefully those patterns you can see, they are going to be really, really helpful because they're going to give us a way to expand those brackets without having to go through that really long process of expanding them manually one at a time. And this whole topic is about that, how we can expand brackets like this without having to go through that whole laborious process, one bracket at a time.